Hello class, welcome to lesson 5.3, which is on adding and subtracting unlike fractions. Just some reminders about some review vocabulary that we have. We have numerator and denominator. Numerator means the top number of a fraction, and denominator means the bottom number. All right, we've also talked about the vocabulary words improper fraction and mixed number. I think the best way to define those is just by the picture that we have at the top of our notes. Okay, so to add or subtract fractions, you must have the same denominator. That is so important. There are many different ways that we can do this, and so I want to emphasize that I am going to show you today how I might solve these, but I want you to know that if you have another method that is working for you, just keep doing that. As long as it is working for you, that's just totally fine with me, okay? So in example 1, it says find the sum or difference. So if I saw this 15 and the 5 on the bottom number of the fraction, the denominator, I want to make sure that those two numbers are the same. So I notice that 5 goes into 15 if I multiply it by 3. Now, whatever I multiply the bottom number by, I have to multiply the top number by the same thing. So my two fractions, the first one stays the same. The second one, 1 times 3 is 3, and 5 times 3 is 15. Okay, now I have 7 plus 3, which is 10, and 15 stays the same. I do notice that 5 goes into both of these two numbers, so I'm going to divide them by 5, which would result in 2 over 3, which would be our simplified answer to letter A. In question letter B, 3 and 4 are not the same bottom number. However, I do know that both of those numbers go into 12 quite nicely. So if I were to take 3 times 4, that would give me the number 12 on the bottom. And if I times the bottom by 4, I also have to times the top by 4. So 4 times negative 2 is a negative 8. And now if I were to do the same thing with this fraction, 4 times 3 is 12, so I times both the top and the bottom by 3. 3 times 3 is 9. 4 times 3 is 12. Okay, now I can go ahead and I can subtract those just like normal. Negative 8 minus 9 is a negative 17 over 12. And I want to ask myself how many 12s go into 17? One of them. And note that because this is a negative 17, this should be a negative 1. Now how many is left over if I take 1 12 from that 17, and 5 would be left over. So my answer is negative 1 and 5 12ths. 5 12ths cannot be simplified, so that is how I would leave it. All right, normally in class at this time, I would ask you to do C and D on your own. I would like you to try those right now to see that you understand this, and you can check your work. I have also posted the teacher's notes on our task list. So please check your work by using the teacher's notes. At this time, I'm going to go down to example 2. Example 2 says simplify the expression. So the difference here is that now we have variables in our fractions. To be honest, you really treat this the exact same way. I need the bottom numbers to be the same. So 4 and 8, they both need to have the same number. Well, 4 goes into 8 very nicely if you times it by 2. So if I times the bottom by 2, I also have to times the top by 2. So 2 times A is 2A, and 2 times 4 is 8. I don't have to do anything to the other fraction. So now we have 2A minus A. And just a reminder here, that's the same thing as saying 1A. It's our hidden number 1. So we have 2A minus 1A, which is 1A left over, and 8 stays on the bottom. You could leave your answer as that, or if you would prefer to not write the 1 in front of the A, that works too. So either one of those two is okay with me. A over 8 or 1a over 8. Okay, letter B is very, very, very similar to letter A. Just make sure that you get 5 and 7 to have the same bottom number. I'm going to let you guys try that one on your own and check your work by using the teacher's notes. Let's take a look at letter C. On letter C, we do have a variable now on the bottom of our fraction. Really, this doesn't change. We need to make sure that both bottoms of our fractions have the same number and variable. They currently both have an x. We need to get the 15 and the 10 to have the same number. Okay, 15 and 10 both go into the number 30. So I know that 15 times 2 is 30. That means I also times the top number by 2. So now we have negative 4 times 2 is a negative 8. And 2 times 15x is 30x. Okay, if I want to times the other fraction, 10 times 3 is 30. So we're going to times 3 both on the top and the bottom. So we have 9 times 3, which is 27, and 10x times 3 is 30x. Okay, negative 8 minus 27 is a negative 35, so we have negative 35 over 30x. I do know that both of those numbers can be divisible by 5, so I'm dividing 5 on both of those. So we will get negative 7 over 6x. 6 goes into 7 one time, and again this is negative, so we keep our negative there. And how many is left over if we pull out 1/6 from the 7? Well, 1 is left over. So we have negative 1 and 1/6. Okay, flipping over to the back side of our notes. To add or subtract mixed numbers, you can write the mixed number as an improper fraction, or you can distribute the operation. So again, there are multiple ways that you could do this, multiple methods. Any method is okay with you. I am going to show you how to use the improper fraction method, but again, if you want to use a different method, that is okay with me too. So let's take a look at example 3, letter A. We have negative 4 and 2/5 plus a negative 2 and 6/11. I do see that 5 and 11 are not the same bottom number, and we need to change these into an improper fraction. So I'm going to take 4 times 5, and then I'm going to take and add that 2. So 4 times 5 is 20, plus 2 is 22. Now, because this 4 was negative, I'm going to make it a negative 22. And then my bottom number stays the same as a 5. Let me zoom this in here so you can see a little better. Okay, we're going to do the same thing with the other side. So we're going to take 2 times 11 and then add 6. 2 times 11 is 22, plus 6 is 28. Because that was a negative 2, it's going to be a negative 28, and the 11 stays the same. Okay, I'm trying to think of the numbers that both 5 and 11 go into. One kind of easy thing to do is just to, if I want to figure out what number to times this by, I just times it by the 11 right here. So I'm going to times both the top and the bottom number by 11. Here's where a calculator would be very helpful. If I were to type in 11 times negative 22, I'm going to get negative 242 on my calculator. It's okay to use a calculator. It'll speed this up a lot. 11 times 5 is 55. Okay, and now let's go ahead and let's do this similar idea to the other side. So I need to figure out what to times this by. A good thing to do is just times it by the denominator of the other fraction, which is 5. It's just a quick method. All right, so again, using a calculator, we have negative 28 times 5, and that should be negative 140. And we have 11 times 5, which is 55. Okay, now just adding these two just like normal. Negative 242 plus negative 140 is negative 382 over 55. Okay, here's where a little calculator work is super helpful. So if I want to know how many 55s go into 382, I'm just going to use my calculator and do 382 divided by 55. And when I do that, I should get a 6 point something something something. Okay? So we know it's going to be 6 whole 55s fit into that 382. And this is a negative number here, so we should have a negative 6. Now, how many is left over? So what we can do is take 6 times 55. And when you do that, you should get 330. So that's how many we took out. So if we started with 382 and we took out 330, how many is left? Well, that is 52. So that is the number that goes right here. And 52 over 55 can't be simplified, so that is our final answer. Negative 6 and 52 over 55. Okay, let's scroll over here to letter B and try letter B. So we're going to do the same style. I want to change these into an improper fraction. So 3 times 9 is 27, plus 5 is 32. So we have 32 over 9. Okay, and we're going to do the same thing. We have 2 times 6 plus 1. 2 times 6 is 12, plus 1 is 13. Okay, now we need to change 9 and 6 so that they both have the same bottom number. So I'm going to take this fraction and I'm going to times it by this denominator, which is 6. And I do that to both the top and the bottom. 6 times 32 is 192. And 6 times 9 is 54. Okay, we're going to do the same thing. So we're going to take this fraction and we're going to multiply it by the denominator of this fraction. So that's 9. 13 times 9 is 117. And again, just use your calculator. That's totally fine. And 6 times 9 is 54. Now we can add these just like normal. 192 plus 117 is 309. So now I want to know how many 54s go into 309. This is where we just do a little side work on a scratch paper or on the side of your paper. Do 309 on a calculator divided by 54, and you should get 5 point something something. Okay? When you do that, that means I'm pulling out 5 whole 54s from 309. So if I want to know how many that actually is, I take 5 times 54, 5 here times 54, and that should be the number 270. So that's how many I pulled out. I need to know how many of that is left. So if I take my original number 309 minus 270, I will get 39. So that's how many is left over. I'm not sure if you see this right off the bat, but both of these numbers can actually be divisible by 3. Okay, so if we do that, we're going to get 5 and 13 over 18. And that is my answer to letter B. Okay, for the rest of these in example 3, C, D, E, and F, why don't you go ahead, you don't have to do all 4 examples, but do like 1 or 2 until you kind of feel like you understand how to do this, okay? And then I'm going to work through with you example 4. That's the last one we'll do together as a class. So it says you are hiking 12 1/5 mile trail. You have already hiked 6 1/2 miles. How many more miles do you have to hike before you reach the end of the trail? So if you think about a trail that is 12 and 1/5 miles long. You have already gone 6.5 of those miles. So we want to know how many is left over. We want to find this amount. So what you can do to find this is you can take your 12 and 1/5 minus your 6.5. All right, now this becomes like a problem just like we were doing it in example 3, where we need to write this as an improper fraction. So 12 times 5 is 60 plus 1 is 61. So I'm going to rewrite this as 61 over 5. And we have 6 times 2 is 12, plus 1 is 13. So 13 over 2. Okay, I do know that 5 and 2 are not the same number. They have different denominators. So we now need to take this fraction and multiply it by, I'll do 2. So 2 over 2. 61 times 2 is 122, and 5 times 2 is 10. Okay, if I were to do the same method with this, I'm going to multiply it by 5 over 5. So 13 times 5 is 65, and 2 times 5 is 10. 122 minus 65 is 57 over 10. Okay, and similar to up above, there are 5 tens that fit in 57 with 7 left over. So it is 5 and 7/10. Now it is important to actually answer this in words because this is a word problem. So how many more miles do you have to hike? You will need to hike 5 and 7/10 miles. And writing that miles at the end of your answer is very important because this is a word problem and that is part of the answer. Okay, that was our lesson 5.3. Please feel free to reach out if you have any questions or need help with anything, okay? Best of luck and I will see you soon. Bye.